going to work on tonight is using Excel to estimate the implied volatility based on option prices. So my example that I'm going to do here is 3M. In fact, I should probably insert a row up here and say 3M implied volatility. Anyway, so what this project is on implied volatilities. It's really going to be in two parts. The first part is you're going to calculate the implied volatility for each one of the stocks in your portfolio, making the assumption that there are actually options offered. I know that Stephanie picked I think it was China Airlines, which was an ADR traded here in the United States, which may or may not have an option associated with it. So if you don't have an option, that's a problem. Just put in your report there was no option available and on which ticker it was. And I also want to give a shout out to Elena, Brenda, and Aaron for stopping by the office and asking some really good questions on their spreadsheets. All right, so let's get started. First thing, I'm using a function here called today, and it's just going to give me what today's date is. And then all the options that you're going to work with are going to be the ones expiring on June 14th of 2014. So we use today here. We type in the expiration date of June 14th of 2014, and we just subtract these two values, and that is going to give us the number of days that are out there between today and option expiration. And some places incorrectly use the number of working days. That's wrong because volatility is a measure of information, and information occurs every day of the week. So on Saturday, a war breaks out, or peace breaks out, or there's an announcement of a new oil discovery, a hurricane, all kinds of things. It impacts option pricing. And that price discovery or that information process is actually compounded in the price of an option. So options are worked based on the number of years until expiration. So in this case, we're just taking before the number of days and dividing by 365 days in a year, since we're not in a leap year. If you do have a leap year and have to incorporate the 29th, it should be taken care of with the today function and the expiration date. All right, so next thing I want to get is what the current call price is and put price is. So nice and simply, we'll just go here to Yahoo Finance. And again, I'm looking for the June 14th. Don't pick the May 14th date. Pick the June 14th. Here is the 140 strike price, which is what I'm using. I'm using the at the money option for the call. The closing price was at 140.61. So you can do this with either the 140, 141, meaning the one that's just below the price, or the option that's just above the current spot price in the market. And this option is worth $2.75. That's its closing price. You'll notice here, I want to emphasize that there's multiple options at the 140 strike price. In this case, there's 3 of them, and you're always going to use the one with the highest trading volume. These other options are slightly different in configuration. We're not going to worry about these details. So that's $2.75. You multiply that by 100. There's 100 shares per contract, so $275 if you wanted to buy. If you sold it, you would sell it for $275. And then our put option, here's our 140. You want the put price, the put, and the call to have the same strike price. And again, there's multiple options here, and we're interested in the one with the highest trading volume, highest open interest, and that's trading at 262. So you'll just enter the 275 and 262 prices. All right, down here we're going to create two separate columns for the call option price and put option price, and you'll see why when we actually do the implied volatility. So we need a strike price. We need the current stock price, which again from Yahoo Finance was 140.61. We need the strike price, which is 140. I'm going to talk about sigma. This is the volatility over the. This is the annual volatility for the option, and this is something that you have to guess at. The risk-free rate, I get that, is the 1-year LIBOR. And again, if you just would come over here and type in 1-year LIBOR, we can click up the 1-year LIBOR rate, which is at 0.55. And this is an annualized rate, which is what we're looking for. And then the dividend yield on the stock is another thing. We're going to do options with dividends. And if your stock doesn't pay a dividend, then this value is just 0. And going back to Yahoo Finance and 3M, and I'm going to pause real quick while I answer the phone. Okay, mindless phone call. Next time it comes in, I'll just mute it. Obviously I'm doing this from home. Anyway, and what we're interested in is down here, the dividend yield. That's the dividend that's paid. This is the dividend yield at 2.4%. And then if I was going to do an ETF, for example, the SPY, you'll notice that it just gives you the yield. That's 1.86. As I recall, that would be 1.86%. It's the yield as opposed to the dividend, and they put the yield down there because you have so many stocks, the dividend kind of floats a little bit. You got 500 stocks underneath this one, so it'd be 1.86% of the closing price of 188.42. So if you're going to have to do the implied volatility for each stock in your portfolio, and some of your stocks are going to be ETFs. The yield here would just be 1.86%. All right. So what we're going to need to do is calculate our D1, D2, and then we're going to use the Black-Scholes option model to get a price for the option. So if I entered in a volatility guess in the future of 16.91%, my option price would be $3.29. So current option price is obviously only $2.75. So the implication here is that, well, there's twofold. Either I'm right and the option should be worth $3.29 and it's actually being sold for $2.75, in which case I want to buy a bunch of these options, or I'm incorrect. Now, when I say I'm incorrect, I have to be incorrect about my estimate of future volatility, because this I'm reading from the internet, which is exactly correct. This is from the contract. This is the risk-free rate based on the LIBOR, and this is the dividend yield. Nice thing about the Black-Scholes option price model, with these 5 inputs, only one of them do you have to guess at. The other ones you just read off various websites. You also need to know when the expiration date is, which of course is part of the contract. So my guess here is that it's my implied volatility, or my volatility guess, that is in fact incorrect. Now, where do you get a volatility guess from? Well, we worked on estimating with the EWMA, and we came up with these two variance covariance matrix. This one is based on an equally weighted variance covariance. Here's my equally weighted variance covariance estimate for the volatility of 3M. And if we just come over here, we take the square root of our estimate of volatility, and we multiply it by 252. That's going to annualize this. And that gives us our 16.91%. On the other hand, we could go to our exponentially weighted moving average, in which case this is our estimate of volatility. And again, we just, since this is a daily estimate, we multiply it by 252 and take the square root of the whole group. Okay? So these are two potential ways to estimate the volatility of 3M over the next year. And if I come back to my estimate and I enter in my 14.42, we see that we get a call price here of $2.83, which is a lot closer to the actual call prices being traded in the market right now. So, key point, if you can come up with a better way to estimate the volatility, this is the square root of variance, but if you can come up with a better way to estimate the sigma, then your guess of the call price is going to be better possibly than the markets, and you can make a lot of money that way. And then if we come down here, we'll do our 14.42 once again, and it gives us an estimate for the put of $2.69, and it's actually trading for $2.62. And there can be a couple of reasons that I'll talk about in class, but we're not going to worry about it in terms of this project. Now, in order to estimate to get this price using Black-Scholes with a dividend yield, we need to calculate our D1, our D2, and then apply the Black-Scholes equation. So what I've done here is show you what the equation is going to look like. D1 is 1 over the standard deviation times tau. Tau is the time remaining in terms of years until the option comes due. So in this case, tau is equal to 0.10958, etc. We're going to multiply that quantity by the natural log of the current stock price, S0, divided by the strike price, which is K. We're going to add to that the risk-free rate minus the dividend yield plus 1/2 the volatility. This is sigma squared. This is sigma in the spreadsheet. And then we're multiplying that by tau. D2 is simple. It's just D1 minus sigma times the square root of tau. Our call price, because we're using dividends, and my wife just got home and she's yelling for me, so I'm going to pause again. I'm sure she would love to say hi to you, though. Alright, we'll try again. They just got back from yoga class. My wife and daughter go together, and anyway, it generates a little bit of energy. Alright, so we've talked about our D2 and our D1, and then price of the call is going to be E to the minus Q. Q represents the dividend yield. Tau is again the time until expiration. S0 is the current spot price. And ND1 is this N represents the cumulative standard normal distribution. And we're going to subtract E to the minus RT. R is the risk-free rate. K is the strike price, and then ND2 is the cumulative distribution again. And as we get into the properties of options, we'll go over in detail what these mean. And then our put is going to be E equal E to the minus R tau times K, the strike price, times the cumulative standard normal distribution minus D2, and again subtracting the second term. Without going into the detail, we'll learn that. Alright, so the next thing we need to do is get our equations in. So here's our D2. 1 divided by B10 which is our estimate of sigma, times the square root of B5, and that's the difference. You notice that this has been $, so it doesn't change, times the natural log of the stock price divided by the strike price. We call this the moneyness term, plus the quantity of B11, which is the risk-free rate, minus the dividend yield, times 1/2 of our estimate of volatility squared, so this is the actual variance, times tau, the amount of time remaining. Once you put that in here, you can just copy it as in Control-C, Control-V, copy the equation over, because we want to be able to run these two guys separate. D2, again, is simply D1 minus sigma times the square root of time. And again, copy that across. And notice the $sign B5, $sign, or $sign B, $sign 5. And then the price of the call, we're going to use the exponential of negative risk-free rate times the tau remaining times the B8, which is the stock price, times, this is the current cumulative normal distribution function in Excel, norm.s.dis. B14 is D2, and the comma 1 means you want it to be cumulative. You could put a 0 in there and you're going to get the normal probability density function. We won't get into the details of that. Subtracting the exponential of B11, which is the dividend, B11, which is the risk-free rate, times tau, times B9, which is the strike price, norm dis, B15, which is D2, comma 1. And then for the put option, it's very similar. In this case, E9, which is the strike price, times the exponential of B11 minus B12. You know what? That's a mistake. Let me pause this and come back. Alright, sorry about that. Making mistakes, everybody does. Anyway. So here's our equation, corrected now. It's the strike price times the exponential. We're discounting, this is continuous discounting, based on the risk-free rate, times B5, the amount of time, times norm dis of negative E15, which is going to be D2, minus the E8, which is the current stock price, discounting that based on the dividend yield, multiplied by the cumulative normal distribution, times D1 negative, it's the negative E14, comma 1. Alright, so that gives us our two price estimates. We're a little high on the call, we're a little low on put. So what we want to do is estimate the implied volatility. So this is our guess in terms of volatility based on the EWMA methodology, which is fairly reasonable. The results aren't horrible. And what we're going to do is use the actual call price and all the other inputs that we know and can read from the internet or from a paper or wherever, and use Excel to actually calculate what the volatility is implied by that price. So in order to do the implied volatility, we're going to go under the data function, and we're going to do a what-if analysis using the goal seek. So in this case, what we want to do is we want to pick the price, and that's going to be equal to our actual value, which is 2.75. And we're going to achieve that by changing the volatility estimate. And then we're going to go OK. So the price is now fixed at 275. The implied volatility coming from the option price is actually 13.97, where from our EWMA it is 14.42. Now here's the key. The EWMA methodology, or calculating the volatility, the equally weighted volatility using the past 80 days, are both based on historic data. This sigma of 13.97 is an estimate about what's going to happen in the future. Okay? These options are priced, this is the average guess of everybody for the volatility of 3M. It's an annualized volatility, but it's a function of this particular option. If I picked the May 14th option, I would come up with a different implied volatility. If I picked the June 2016 option, I would come up with a different implied volatility associated with it. And these implied volatilities float up and down depending on how far you are away, how far your strike price is away from the current price of the stock, and how far your option has until it actually expires. So in this case, we're dealing with 40 days. What's known as the near option is the May 14th, and this would be the next option, or the far option, in July. In our analysis, we're going to consider the June options as the near options to give you guys time to calculate everything. Alright, so we just hit OK. We're good there. We can go ahead and do goal seek here. What if analysis? We're going to do a goal seek. We're going to set this value to 2.62. And we're going to do it again by changing the sigma value. And you'll see that the implied volatility of the put is different than the implied volatility of the call. So the question becomes, well, what is the implied volatility of the 3M for the next year based on this particular option? What's the annual implied volatility? So there's two ways to do this. Well, there's several ways to do this. The first thing you can just do is add these two guys together and divide by 2, which is fine. Another way that is done often in markets is, again, we'll go back here to our 3M and our options, and we'll hit on June. And you'll see here for the 140 we had 287 calls trade today. And for the put at 140 strike, we had only 43. So if you have more calls than puts, obviously people buy calls because they think the price is going up, then the implied volatility that comes out of the call option should be more than the implied volatility weighted wise than the put option. So the actual implied volatility is going to be this function right here. Go ahead and OK this. So the implied volatility is going to equal the volatility that's coming from, we'll make this a quantity, implied volatility from our goal seek, multiplied by the number of options, the call options that are out there that were traded today, which was 287. Times 287. We're going to add that to our implied volatility from the put, multiplied by the number of put options that are out there. Just to verify, it is 43. And then we're going to divide that by 287 and plus 43. This is known as the weighted average implied volatility, which is at 14.10%. So we went through this long process to get a estimate of the spot or the point volatility for, put that in percentage terms, for the EWMA process, and we came out with 14.42. And if we used options to do it, we would have ended up at 14.11. As opposed to our equally weighted volatility measure here, which is at 16.91. So the equally weighted volatility is higher. In other words, it's estimating more risk than what is implied from the option pricing model. Okay? So your goal is going to be create this sheet for each one of your stocks. And this needs to be done, well, basically by Thursday. And what we're going to do is once you have your implied volatility calculations, we're going to track the price of the stock over the next couple of days, or the return series of the stock, from here until probably the 23rd or 22nd, and see what the actual annual volatility is coming from those price returns, and then compare that to the implied volatility. What we want to do, what I want you to see is how accurate or inaccurate this measure of implied volatility is in fact going to be. So that's part one of the project. The second thing that we're going to do is we're going to use each one of our implied volatilities from our put and our call. What we know is the at the money put and call. So this is the put and call that is either one strike price below the current stock price or one strike price above the current stock price. That becomes our implied volatility, and then what we're going to actually do is come back and plug that on the diagonal, holding the covariance matrix the same, and then that's going to adjust our weighting matrix, and it's going to adjust our daily standard deviation, which is then we're going to use to re-estimate our value at risk. That's the second part of the project, and this is kind of like the capstone project, because you're going to need to, and I'll go over this in more detail as we go forward, you're going to compare these different methods of how to assess your risk, which is implicit in how to assess whether you need to hedge or not. And then we'll go over 3 different mechanisms for hedging. We've already talked about the futures contracts. The second one we'll do is option contracts, and the final one we'll do is options on futures. All right, so that's good. We'll go over this on class on Tuesday. We'll see you then. Thanks.